we want to talk about the coefficient of determination. The coefficient of determination is represented by the symbol r squared. Hop back and forth here. And r squared is equal to the explained variation over the total variation. Okay. In our example that we have here on this page, we said our explained variation was 774.71 out of the total variation of 805.34. When we divide those two numbers, we get 0.962. Now the coefficient of determination is usually given as a percent. So if I turn this into a percent, my coefficient of determination is 96.2%. Okay. What the coefficient of determination tells us, it tells us the variation of the dependent variable, okay, how much of the independent, or let me start over. It's the measure of the variation of the dependent variable that's explained by the regression line in the independent variable. Okay, so as a percent, that means 96.2% of our total variation is explained by the regression line. Okay. Now notice this isn't a coincidence that we use the letter r here to describe it. If we go back to our r value, our correlation coefficient, and we square 0.981 on our calculators, we get 0.962361. So this r squared value, okay, this r that's sitting here is the same as the r that we used back in 10.1 or whatever the section number was. If 96.2% of our information is explained by the regression line using the independent variable, then if we talk about the coefficient of non-determination, it's the other piece. So that would be the other 3.8% would not be determined by using the regression line. If you have an r value of close to 0, an r squared value will be close to 0, and that really means that it's not helpful. But again, we wouldn't have drawn a regression line if our r would have been that small to begin with. If we want to find the standard error of the estimate, we can talk about finding what's called a prediction interval. We've done confidence intervals where we told the reader that we are 95% confident that the true population mean was between these two values, or the standard deviation was between these two values. Okay, now we can create a confidence interval. It's not a confidence interval, a prediction interval that says if we are between these two values, then our regression line is doing what we want it to do. But if we step outside those parameters, then we really shouldn't use that regression line. Okay, to find the standard error of the estimate, type per minute, standard error of the estimate. The formula for that involves finding or using values that we've already found. Okay, we draw a straight line. We are going to take the sum of the y minus y primes squared over n minus 2. For the example that we just did, our y minus y prime squareds, that's 30.81. We had 6 data points, so n minus 2 is 4. And if we take the square root of that, we get 2.78. What the standard error of the estimate measures, it measures kind of the standard deviation from how the points differ from the regression line. Okay, the regular standard deviation talks about how points differ from the mean. This is of the squares. It's kind of the mean of the sum of the squares of those values. But instead of checking for difference from the mean, we're checking for difference from that regression line and its prediction. Okay. Now to make the prediction interval, you would have one for each value of x, and the truth is that formula is hideous. It is in your book, and I'd like for you to look it over and look through the book examples and what they do. But this isn't something that in a timed setting would be reasonable for me to ask you to do much with. Okay, so I will ask you to practice some standard error of the estimate stuff in the total variation things, maybe a couple of exercises from here, but we're not going to worry about finding the prediction interval um, because at this point in the semester we're just going to call it good. It's honestly how I'm going to say that. So please get a hold of me if you need me, and read in the next link for your exercises that are assigned, and have a good day.